All right, so in example 4, it said write tangent of arctangent of 1 plus arc cosine of x as an algebraic expression. So remember we said that first thing is I'm taking tangent of these two things. Well, when you take the arc of anything, you're looking for an angle, correct? So these are just two different angles. So we're going to let those be u and v.
Ours says sine of.
Oh, I forgot about that. You're right. Ours does say sine, so let me change that. All right, so sine of u plus v is what we're looking at. All right, so, and we know that the sine of u plus v formula says sine of u cosine of v plus cosine of u times sine of v, correct? Now, we said that u is what?
Arctan of 1.
All right, so where I have u, I'm going to put arctan of 1. Cosine, what did we say v was? Arc cosine of x. And then cosine of, what was u again? Good, and then sine of v, I'm out of room. Sine of v is the arc cosine of x.
And then we left at that point, right? Yeah, that's basically
Okay. So, in order to do, well, we need to find sine of arctangent of 1. So I'm going to come over here and make a little workbox. So sine of arctangent of 1. And this is like what we did in 4.7. So we're going to let what's in the middle here, the inside, be our theta. So really I'm looking for sine of theta. If I knew what theta was, then I can find the sine of it. So we got to work to find what theta is. But we already know, we said that that inside, that arctangent of 1 was going to equal theta. So remember, arctangent is just the same as the inverse. So let's take the inverse of it. So the inverse of arctangent is tangent. And then when we take the inverse, we switch the x and y. Well, this is my x in this one, and that is my y, so switch them. So tangent of theta equals 1. Now, because we're looking at the arctangent, we've got to think about what was its range, because technically the theta is my range. So the range of arctangent is negative pi over 2 to positive pi over 2, which means it's in quadrants 4 or quadrant 1. Now, I need tangent to be a positive 1. So what quadrant are we in?
1.
We're in quadrant 1. So which angle, when I look at my ordered pairs, and tangent is what in terms of x and y, since it's an ordered pair?
Y over.
Tangent is y over x. So what angle in quadrant 1, when I take the y over x, will it give me a 1?
Pi over 4.
Pi over 4. Or we could say 45 degrees, right? Because y'all seem to do better in degrees. Because y and x are the same thing. They're both the square root of 2 over 2. Alright, so I know my angle is 45 degrees, or you could put pi over 4. So this means I'm looking for sine of 45 degrees, which is what?
Square root of 2 over 2.
The square root of 2 over 2. So that's what I put in for sine of the arctangent of 1.
Think for the next one.
Okay, so we found that sine of arctangent of 1 was equal to what?
Square root of 2 over 2.
Alright, so we said sine of the arctangent of 1 is square root of 2 over 2, correct?
Cosine's the same.
Well, then we got to do the cosine of the arc cosine of x. Well, cosine and arc cosine are what? They're inverses. Okay, and when you take the inverses of each other, they end up canceling. So we end up with x plus.
Well, would you add the x to both of them, or would you just put it?
It's just times x right now, okay? We'll deal with that in a minute. Now I've got to go and do the cosine of arctangent of 1. Well,
The sine, because in that quadrant.
we already said that the arctangent of 1 equals theta meant our theta was what? 45 degrees. Hold on a second. So if I'm looking for cosine of that arctangent of 1, you already told me arctangent of 1 is 45 degrees. So what is cosine of 45 degrees? So we're going to replace that with the square root of 2 over 2 times. Now, we got some work to do on this. Okay, so then we have the sine of the arc cosine of x, and I've got to erase this, so we have some room to work. So we're looking for sine of arc cosine of x. Well, just like earlier and before, let's let our arc cosine, we're looking for an angle, so we're going to say that's theta. So again, I'm looking for sine of theta. There could be. So let's go focus on that arc cosine of x then. We said that's equal to theta, which remember, go ahead and take the inverse of everything. So the inverse of arc cosine is?
Cosine.
And then switch your x and y. So if theta equals x. Well, I know cosine and I need sine. So how are we going to do that? What do I do if I know cosine? Good, you're going to use the Pythagorean identity. And so we got, is that sine squared plus cosine squared equals 1. So we got sine squared plus x squared equals 1. Alright, so then you've got to get sine squared by itself, so subtract the x squared. Guys, pay attention. So you get sine squared equals what?
1 minus x squared.
Good. And then how do you get rid of the square on the sine? Square root it.
You can't take square root of that.
You can't take the square root of 1 minus x squared because of the minus. But so you leave it together. So you end up with sine of x equals, I'm sorry, it should be theta because that's what's in our problem. Sine of theta equals plus or minus square root of 1 minus x squared. Now,
So then we put that in for the parentheses.
well, we've got to figure out, though, is sine going to be positive or negative?
Sine
for this problem.
would be positive.
Why positive?
Wait, we're in quadrant 3, right?
I don't know. How do we know what quadrant we're in?
Well, if cosine's positive, and sine's positive.
Well, but again, this came from that arc. So you got to think about its quadrant. I shouldn't draw it out that far. Uh-oh.
Sure.
All right, so think about that arc cosine. We're looking for the angle, so we're looking for the range of it, which is between 0 and
1.
pi. So what quadrants are between 0 and pi?
1 and 2.
Quadrants 1 and 2. Well, we don't know which quadrant, well, I guess we do. No, we don't. We don't know what cosine was. We just know it was x. So we don't really even know if that x is a positive or a negative number. But in quadrants 1 and 2, what do we know about sine in both of those?
It's positive.
It's positive in both of those quadrants. So we're looking at the positive square root of 1 minus x squared. So that's what I'm going to put here. The positive square root of 1 minus x squared.
I was right.
Now, the hard part's over with. All we have to do now is
Distribute.
multiply, distribute, and combine. So, square root of 2 over 2 times x. I can put that as x over 1. And I'll get what? X square root of 2 over 2?
Yeah.
How did I get that?
You multiply it across.
Multiply straight across. Good. Plus, and then this I can put over 1. But I'm going to write it out this time. So, square root of 2 times the square root of 1 minus x squared all over 2. And how do you multiply with radicals?
You have a common and...
Wait,
no,
just
not
multiply the
multiply.
stuff
Just
on the
go
inside.
across.
Okay, as long as the radicals are the same, they're both square roots, then you can multiply what's underneath. You can multiply or divide, but you cannot add or subtract what's inside, okay? So we can take this 2 right there and distribute it into the other one. Now so we get x square root of 2 over 2.
Unless they're the same. Or is that only when you add?
Say it again.
I thought you couldn't distribute the square root of 2 unless you were, is
They're-
that only when you're adding?
If they're exactly the same, your radicals have to be exactly the same in order to add their coefficients. But with multiplying, as long as it's a square root of some number times the square root of something else, then you can multiply what's underneath, as long as they're both square root. Okay? The radicals have to be the same, but what's underneath doesn't. It's like earlier in one of the examples, we had a square root of 2 times the square root of 3, and y'all told me it was a square root of 6, okay, because we were multiplying. Now, we couldn't add them because they're different, but we can multiply them.
Right.
So, back to this, so it's over 2, and then can I add those fractions?
Yes.
I can put them together.
Because they have a common denominator.
Yes, you can. Over, let's see, x squared root of 2 plus square root of 2 minus 2x squared all over 2. Now, can I add those
You can't go
radicals
too far.
together?
No,
Why not?
because they don't have the same.
They don't have the same thing underneath the radical, okay? So this, it would be as far as we could go.